Yay! We're live. Good morning. Hello. As I usually say, hello, GitOpsians. I took down my joke t-shirt store where you could actually see that on a t-shirt. So sadly, that's no longer swag. Maintaining a joke t-shirt store was way too much work. I'm not gonna lie. It was fun for like a year and a half, and after that, I was like, I'm so over this. But anyway, no announcements this morning, which is means it's a very quick intro. Today's stream is about observability. This was requested by this was a requested topic from the audience back when we were talking about observability as it pertains to Argo CD. So we brought in some Red Hat observability experts to talk about, and when I say observability experts, caveat, like it's a huge space. There's a lot of ways to build expertise within it. But our particular guests today actually work on observability technologies. So I'm going to go to my left. I don't know how it looks for everybody else. I'm going to go to my left and let Jan introduce himself, and then the rest of the team can like popcorn it around.
Sounds good. Yeah. Hello. Good evening. I'm Jan. I'm currently the team lead for the OpenShift monitoring team. Been doing this for a few years now. And yeah, day-to-day work is usually with Prometheus, and that's either upstream or whatever we do within Red Hat with it. And I pass it down to Saswata.
Yep. So my name is Saswata Mukherjee. I've been with Red Hat for around 3 years now, and I'm a senior software engineer on the team that Moaz is the team lead of, called MultiCluster Observability, and we deal majorly with Thanos. And so we deploy Thanos for other teams to send and query metrics from, as well as ship Thanos in a sort of multi-cluster product known as Advanced Cluster Management. I am also an upstream Thanos maintainer. Have been a maintainer for around a couple of years, I guess. Maintainer of some other CNCF adjacent projects as well. And I also mentor certain students as part of LFX. So yeah, that's me. Over to you, Moaz.
Thank you. I'm Moaz. Saswata has done the difficult part for me and introduced me as well. I work with Saswata, who's awesome, and we run MultiCluster Observability, as you mentioned. We run it in two ways. We build a product, and we also run it internally for Red Hat OpenShift. So we have an interesting experience of observability, both as contributors in the open source, but also as people who package it for customers to run on-prem, and also people who actually have to use it day to day and run it and maintain it. So yeah, before Red Hat, I used to work in video games. So I did some observability stuff there as well. And I've been at Red Hat for a couple of years now.
Awesome. So you are the like perfect example of drinking our own champagne.
Exactly. From both ends.
From like literally like also growing the grapes practically, like the whole 9 yards on that. So that's pretty fun. I love that perspective. So I know that you all do have some slides to guide the conversation that you could display. We could also just talk a little bit more generally. Do you want to start off with your slide?
Yeah, absolutely. The slides are visual aids. In corporatees, we use them to guide conversation. But basically, the topics we want to cover today are pretty open-ended at the beginning. What is observability? What does it mean to have observability? Why is it useful in a cloud context? Why is it becoming more and more important? As someone who uses it daily, as I'm sure many people do when they build software, it's a very, very critical tool for us in informing, not just in running our software day to day, but also in deciding about what we should do with our software, how we should improve it, where the bottlenecks are, some issues that we might be running into, preempting incidents, which we can talk about as well. So observability is a very broad topic, but in the cloud native world, it's consolidated behind some pretty key projects. We mostly focus on monitoring, but we also have colleagues who operate in logs and traces and continuous profiling and network observability. So that it's a very broad topic, broad church, lots of thoughts, but the fundamentals are very similar between all of them.
Yeah, just to interrupt you, gosh, how long ago was that now? A year and a half ago or something. I had the distinct pleasure of being on. There's a Harness is a GitOps company. They have a podcast called Ship Talk. And so I was on there, and I actually talked about the fact that we get all of this data. We have all of this data for observability. And if you only use it to respond to incidents, you are kind of missing a great opportunity. I say this again. If you're gathering the data, if you're storing the data, if you are spending the resources to do that, it is irresponsible not to use it proactively. I will go ahead and I will state that. So I'm really glad that you talked about that, because I was totally going to bring it up if you hadn't. It's there, right? It's there.
Yeah.
Things.
I'm a huge advocate for it. Yeah. And it's really hard to do. It's really hard to do properly, because it's almost like, when you're learning, maths as a young child, and you're having to think out loud and tell people what you're doing before you do it. Having to do metrics before you actually build any software is quite difficult to wrap your head around, because it's very abstract. You don't know what you're measuring yet. But once you get into the habit of doing it, making decisions about what you need to improve or what you need to prioritize becomes much, much easier, because you have the information. It's tangible. It's live information. We have users, for example. We have operators that ship on OpenShift, like open source operators, and they instrument their workloads. And they do something really interesting, which it isn't just, hey, I've installed, I'm this version. They also instrument the errors that they run into. Like generally, you might run something, you run into an error. It's a recoverable error. It doesn't have to be critical. But they instrument this across everything that's installed, and they aggregate it and gather it. And they can, for example, make decisions about bugs that they think they need to fix, or parts of the stack that they need to improve, based on the trending data of the kind of bugs that people are running into. And you just get that for free by instrumenting your application in a very good way. And then figuring out how to store all of it, which we'll talk a bit about. Yeah,
the storage is fun. You talk about two things which feed into other topics that are interesting for me. So like the first is the that they prioritize bug fixes by understanding how often bugs are encountered. There are always bugs. Right? That's one of the things. Like, I think you've done a really good job of shipping software if you know what your bugs are when you ship it.
Right, yeah.
But there will always be bugs like that. You're never bug free. The idea of bug free is I've never seen such a piece of software. The other thing is you said it's really hard to know what to measure if you don't it's abstract. One of the ways that we kind of ground this in SRE land, where Red Hat SREs are also contributing to the actual development of the product that our customers consume, right? Especially on the Azure OpenShift Red Hat team, Azure Red Hat OpenShift team. God, the dyslexia is real. So ARO, right? We build ARO as the SRE team, right? We do the build out and the actual day-to-day running the service. And so one of the two things that we do is the idea of an SLO, right? A service level objective, which is a thing that you can sort of define. Yeah, it's helpful to know what data you might analyze to determine whether or not you're hitting that. But it actually should be defined based on the user experience, right? So if you go, okay, I want my users to be having this experience, right? It's like a measure of one of my colleagues put it as a it's measuring how delighted your users are. I think her name's Lisa. She gave a talk about this at DevCon US in Boston a couple years ago. I think the recording's up, so 10 of 10 recommend somebody go find that and watch it. She's her take on this is really great. And this ties into a project management strategy called critical user journeys. And so if you start off building your software with a critical user journey, right? And that is not just what are all the functionality of our software, not even what are all the end-to-end things. It's what is the most valuable end-to-end actions a user will take, and what is the expected experience of that user during those actions, both overarching holistically and kind of point by point. mapping that out and doing that mental exercise helps guide how you're going to implement observability, how you're going to implement profiling, what you know you need to measure. It gives you your starting point. And so I always tell people, when you want to build an SLO, start with one. You want to map out a critical user journey, start with one. And a critical user journey may have multiple SLOs encompassed in it. Like, this is the overarching story of your software. So that would be like, that's how I think of it relationship wise, is you may have multiple like objectives within it. Because like, if I look at it for the Arrow service, right, a critical user journey is you have to be able to install a cluster, right? And so like cluster installation success is a legitimate SLO. Like, this is successful this amount of the time, right? But then you can also have more minor goals that could be SLIs along the way. But it's also like, I need to be able to install, like, I need to be able to expose a route, right? Well, that's actually a longer story, because the cluster installation is a step on the expose a route, right? So then you have, then you're going to start having like multiple steps. So the journeys can get longer. It's a great project management tool. There's a lot of resources out there on reading up on it. 10 of 10 recommend for anybody.
There's a really good, there's the SRE book, the Google SRE book, that is probably the Bible as far as it comes to SLOs in terms of why they're important when you're running
that
a service.
One, there's they have a couple. There's a site reliability engineer.
It's backwards.
It's
there's an online
site reliability workbook. Yeah, there's
the online version is open for everyone. It's a very good book.
Yeah.
The really interesting thing about us. Sorry, go ahead.
I was gonna say, there's like this one. It's a companion to the other one.
I think there's a smaller one.
There's like a there's the big ones. There's the small ones. There's like 5 million books on and writings on this topic. I haven't found a bad one. Let me just say that.
Yeah.
Whatever one you pick, I haven't found a bad one.
And it's mostly because the principle is like very fundamental, which is that you can't improve something if you don't measure it, and that you should really try to measure things as your user experiences them, not as you perceive them. So you might be really obsessive over like, latencies, like request latencies between these two systems, but you might be operating in a big machine that, is on the second scale, and you're worried about milliseconds. And maybe it doesn't actually matter that you're improving this as much as you are. There's also a really interesting dynamic when we introduced SLOs as well, for how you perceive the performance of your system as well. So it gives you a target. That's a good thing. Like, you want to improve your SLOs because you improve your user experience, but also you put a number to your performance. It's kind of like a letter grade. So if you have very loud customers who say, for example, hey, my requests are really slow and they're hanging, and you don't have SLOs, or you don't have metrics to say otherwise, it's very hard for you to tangibly refute or even decide how you're going to improve it. But just having the SLO in place is a good way to sense check and health check, your system is operating as you expect it to. So absolutely, Hilliary, like, the metrics aren't just specific to, hey, this is a bug or this request errored. You have to think that software nowadays is very complicated. It's often distributed across the world, across different clusters, across different availability zones. It's not kind of good enough to be that granular alone. You need to build levels and levels of complexity above it. So that's kind of the framing of the problem we want to talk about. We're focusing specifically on metrics because that's what we focus on. But very briefly, there are other things as well within observability that are super useful for this journey. There are log lines, which we're all very familiar with and are probably older than metrics to some extent. In everyone's first program, everyone's first Hello World program, they'll pipe something to std out, say hello world. It's basically the fundamental of logging, right? It's doing that across multiple, running containers or aggregating them across clusters as well. It's more verbose, it's text. It's not a metric that you aggregate, although you can aggregate over logs. So those exist. There's also tracing, which is probably the newer one of the bunch, although there are newer ones now. But tracing is effectively a way for you to, or distributed tracing is a way for you to kind of measure and annotate the journey of a request through a distributed system, or even through a single non-distributed system, through a monolithic system. And it basically gives you these really nice flame graphs that says, you know, hey, this request you spent, I mean, you may have seen it if you've profiled an application before and you've looked at a CPU flame graph. It's very similar to that, but you're building it as you go across multiple different systems and hops for your service. So traces are really important as well for when you're digging into a particular thing in more depth. There's continuous profiling, which is a newer one. We had there are some really cool players that are operating in the world of continuous profiling, which is similar to profiling, but you kind of just do it all the time. And that way you have some historicity to your profiles that you can compare, like before and after a change. How has my application performance changed? So you go from like the aggregatable, if that's a word, and kind of things that you can sum up across an entire fleet, to now you're drilling into a particular service that's producing a log line, to a particular request, to, you know, what's actually happening on the CPU through continuous profiling. So between that, you can kind of reconstruct what you would normally enjoy in your local machine if you're building and you have access to everything. So that's the very broad view of observability.
And of course, I mean, that all comes with a nice UI, hopefully, right? That's sort of the overarching thing. And there's some really interesting work happening with some colleagues of us who do sort of correlating these signals. So, you know, be it an incident or just a weird behavior, when you get an alert, you can click into like a dashboard and it shows you all these signals like right next to each other, right? That's really where this becomes nice and powerful.
Yeah,
so
I think
UIs.
There was something we talked about when Christian came on. We were talking about this in the context of Argo. Is there's data and there's information, right? Because the example we had showed on the screen was like, all right, you see this massive spike, right, in CPU because there was a fresh install, right? So then it's like, what is the scale? Well, the scale was 0 to 1, so it's this, you know, what's the zoom, what's that, right? So all of those pieces, right? The context, what's the context, right? You can see a massive spike in resource utilization because an upgrade occurred, right? So the data shows you like a change. The information is the context that makes that data meaningful, right? And so that is a really, I think, important part of the story of observability. This is one of the things that as an SRE, when we're working on an incident or investigating something, that you have to piece all of these things together in order to make it make sense. Because if somebody is saying, whoa, everything is suddenly grinding to a halt, right? Okay, well, that tells me there's probably like, our CPU is exhausted, most likely. And so I can go, if I go and I check the CPU and I do see like, yeah, look at that. That's huge. Okay, well, I know why there's massive latencies, but why is the CPU being used, right? And there's another thing that goes into, which is the 5 whys. Ask why 5 times, and then you're going to have the real thing. So I do want to, I don't think there's any question there, just thoughts. There is a question in the chat, though. I'm going to go ahead and display it on the screen, and I'll read it out for you, which is, I always get confused between metrics and application metrics, and how do they differ?
I mean, I don't think they differ in that metrics that you collect will come from various different sources, whether that be your infrastructure or your applications. And so that simply is a category of like how you want to split out your metrics maybe within your observability systems. So yeah, that's the difference, I think.
Yeah, I would agree. I think I was gonna say, I think it's metrics is umbrella, application metrics is what is under the thing. I'm going to expand on that slightly, and I'm really sorry to cut you off. As somebody who is operating like a platform as a service, right? OpenShift as a service, right? The application metrics are the request like response time, right? So if I have an API and it sends my application has an API, and the API is like sending and receiving calls. There we go. That's the word. And it's taking my API 500 milliseconds to respond, right? That's an application metric. I need to then put that with platform metrics to understand the holistic picture of what is happening. So it's really just, it's a differentiation to determine the source of the data and what the data is measuring, right? Because there's the application and then there's the platform. And so I think sometimes we shorthand it, say application metrics versus metrics, because saying platform metrics is a mouthful. But that's really like, at least when I'm talking about these things, that's really kind of what I'm like the approach I'm coming from.
Exactly. And I think like with observability data, you have this common pattern where you're always looking for the data that you don't have. Like, okay, something fails. I know this metric tells me that it fails, but why does it fail? And then you go and drill down and look at more stuff, right? And so, as you mentioned, like with information, I think a large part of observability data is also the metadata associated with it, whether that be in the form of labels or something else, which kind of allows you to correlate different signals and arrive at a conclusion or at a picture or at an answer to a why question. But yeah,
I'm so glad you mentioned labeling data, because that is such. I feel like labeling data is so powerful, and it's also the number one thing that can spin out of your control the fastest is the management of those labels and having them continue to be meaningful. Maybe put a pin in that. Hopefully, maybe it's something you guys come back to later. I do want you to kind of be able to talk about. We've put a pin in several things. We've talked about storage. We've talked about this, right?
Yeah, I agree.
I think.
Sorry, go ahead. Yeah,
will be our that's a fundamental trade-off that you need to make in metrics observability, right? What labels to add, but we'll get to that.
Right. So this is the virtuous cycle that we've already been talking about, which is better visibility, is better understanding, is a better system, and that starts with better instrumentation. But most importantly, this is always an iterative journey. You will never reach peak observability, right? So it's always going to be an iterative process where you improve things as you go. And the important thing for us as maintainers of tools for this is that we facilitate this process really easily. And we make it very easy for users to understand these things and gain visibility on things that are important. Jan mentioned Correlator and the UI, the Perseus, which is the UI project that we're working on, dashboarding. So there's a lot of stuff that goes into it. It's very complicated. I won't dwell too much on this. But Jan, do you want to tell us a bit about Prometheus?
I mean, does it need introduction really? I mean, it's been around for like 12 years now, right? But yeah, I mean, Prometheus is pretty synonymous with metrics observability, right? And it's really mostly a time series database that's really efficient at storing metrics and querying metrics, and that's metrics with a lot of labels, right? We'll talk about the data model there in a second. I think the big things that Prometheus did right when it came out was obviously the pull-based model that's always been talked about with Prometheus, right? So that it doesn't get hammered by things wanting to send it metrics, but it can decide I'm getting metrics there now and I'm getting it there now, so it can do some nice scheduling. And the service discovery was sort of the new fancy thing right before with. I keep forgetting by now what these systems were called, right? The old metrics observability systems where you had to configure every service you wanted to monitor. Prometheus now has like fancy dynamic ways of discovering all these services, which really suits the cloud native world really nicely. Though it actually predates Kubernetes, which is interesting to know. It was just around the time when sort of systems started managing containers, right? Containers were a thing, but Kubernetes wasn't yet. So it actually predates that. But yeah, and of course, querying, you get a nice query language, a fairly rigorous one, if you will. It has a very well-defined data model and behaves fairly well. It's a little complex to onboard onto, but I think everybody gets the hang of it.
To give an idea for how esoteric it is, sorry, Hilary, our old colleague, Ian Billett, gave a talk at a conference called, and this was before he came to Red Hat, a talk called PromQL for Mere Mortals. So it is a bit difficult to get, but once you get into it, it becomes an extension of your limb. It's quite useful for the things you use it for. Sorry, Hilary. Go ahead.
Yeah, I was gonna say I liked the use of nice query language because it's definitely Well defined, yes. But I was nice was almost ironic because the learning curve on that was not insubstantial.
No, it's true. But once you start to get a hang of it, it's actually quite elegant, and you can do a lot of fun things with it. Speaking of presentation, there's plenty of presentations on PromQL, right? So PromCon just happened about a month ago, PromCon 24, and there was a talk titled "The Weirdest PromQL You'll Ever See." So if you want to see sort of the immortal spectrum of it, then check out that talk.
The immortal spectrum of it. Oh, that would have been a good T-shirt if I still was doing the joke T-shirt store. That would have been that belongs in that. That's good.
Yeah, and I guess it's it's very restrictive. It kind of tries to help you by being really restrictive. It's kind of like a stern parent, where it's like, no, you can't do that. You shouldn't be doing that. Because we see, interestingly, we expose Prometheus metrics in some interesting ways. So we have like PromQL, which is what you use for defining SLOs and alerting, and what a lot of people are familiar with Prometheus. But we actually have a bunch of consumers of our metrics that don't use PromQL, that load our Prometheus data into a column store, and they'll use SQL or SQL-like notation to access it. And accessing like time series data using SQL is super painful as well. So it gave me a whole other appreciation for PromQL, for just being like, actually, for what I'm trying to do, this is good enough in most of the use cases. But it is a bit esoteric. I do agree with that.
I think once you get in it makes sense, right? Which is to say that it's once you know it, it's elegant. When you get in it makes sense. It's so, I think, intrinsically tied to the way that Prometheus works that that helped. The other thing is that the power of this whole thing is like this is something that we have done with a couple of our operators is you can use Prometheus to normalize data, right? By using a Prometheus exporter, you can basically turn almost anything into Prometheus data, and now you've normalized your data. Once you've normalized your data, all that, like what we were talking about earlier, like gathering context and everything else like that becomes a lot easier. So
absolutely,
the rails that the language, the query language, like kind of keeps you on, how it's integrated, like it all kind of makes sense. And in the end of the day, it is the power of the thing. There's actually a relevant question in the chat, which maybe this partially answered, which is Prometheus has been here for a long time. What are the limitations of it, and also thresholds, like number of metrics it can handle? And is a cluster of Prometheus available for high availability at all? I'm not 100% sure I grok the question, but I'll leave it for either further clarification, hopefully from the chat, or your interpretation of it.
Sure. Yeah. I mean, excellent questions. So just a brief excursion maybe into the data model. This is what Prometheus stores, right? There's a time series identifier, which usually people talk about a metric name and the labels, but internally the metric name is just another label. So that's really all there is. And then you get samples, which is a timestamp and a value pair, right? Nothing else. And yeah, so these labels are what we've been talking about before, right? And every sort of permutation of these label values creates what Prometheus calls a time series. So you can see there's like 3 metrics here. They have all the same name, but they're actually individual time series because they vary in the instance label. And so they create a new time series. And if you talk about sort of the limitations and the scalability of Prometheus, you always talk about how many time series can it handle and how many samples can it ingest on every scrape. And frankly, probably more than the rest of your system can handle is our experience. So we, just to throw out some numbers, a decently sized Prometheus node can ingest millions, tens of millions of samples every scrape, which is typically like, every 10 seconds, 15 seconds, something like that. We usually on I think I can divulge this here, on customer clusters, we usually see them not being able to schedule big enough nodes for Prometheus to just have enough RAM to keep ingesting data. So it's not Prometheus that sort of runs out, but you just can't throw enough memory at it to actually put that data somewhere. Even if you, and that's what I want to kind of get to, right? It's like knowing what to monitor. That's the real trick. But even if you don't know that yet, you can throw a lot of metrics at it and figure it out on the way. But eventually, you'll have to deal with it. You'll reap the harvest of your laxity here.
I also think.
Go ahead, Hilary.
Sorry, I was saying the other thing to consider is not how large can I scale Prometheus, but really when you're measuring that many things as an SRE, I start to question like how big is your cluster, and have you considered whether or not the cluster sizing is appropriate for your failure domains? Meaning, if that one cluster fails, what happens for you? Have you split your considerations adequately enough to be doing what you need to do as a service software provider, company, etc.? So that starts becoming a question to me, because you can scale it, I guess, nearly infinitely. I'm sure there is a limit somewhere, but it's pretty bare bones, right? It's not that intensive of a thing in like its base behavior. So when your scale of measure within one cluster, and I know we're going to talk about multi-cluster, and that's a whole different thing. When your scale of measure within one cluster with one scope is that big, then I'm questioning have you really thought this through in terms of like a disaster recovery or at failure domains? So that would be the other thing to just kind of keep in mind when you're considering like how big do I want to scale Prometheus? How big do I want to scale this cluster? How big do I want to how do I want to actually lay out my fleet? Those are things to keep in mind. That's part of the scaling decision.
Yeah, absolutely. The only thing I would add to Jan's comment is that in the systems that we maintain, there are some services that we maintain that consume, and this is not just Prometheus, this is Prometheus plus Thanos, but we consume in the order of hundreds of billions of samples in a given day of data. And I don't know about everyone on this call or everyone who's watching. It's a lot of data to potentially wrap your head around and use on a daily basis. At the end of the day, we are mere mortals, as the talk would suggest. Like there is probably a point very, very quickly where you're ingesting more data than you could reasonably consume in an effective way. So in terms of bottlenecks, it's usually how much you're willing to pay and how much is really technically necessary.
Yeah, I would say it's more of like a limitation of the infrastructure that you run on. Like you can scale pretty much anything Prometheus quite a lot, but really it's a decision, as you mentioned, like around how you want to structure your fleet, how you want to structure your workloads. If your workloads get over instrumented, which is also kind of a thing, like you can add a bunch of metrics to a very simple thing and observe everything, but do you really need to? But yeah.
And then, of course, there's the people who mistake Prometheus for a logging system and try to shoehorn a lot of stuff into label values, which is always fun. But really quickly, just there was also a question about high availability, and I think that's actually a good segue. So Prometheus itself does high availability. Basically, you just deploy the same instance twice, and you have high availability. It's a very sort of simplistic way of doing high availability, which has a lot of value to it because, the two Prometheus instances, they don't know each other. They don't need to synchronize. So there's just fewer things that can break. But once you want to query things, of course, you need some layer that resolves this duplication of data. And that's really where Thanos comes in and shows the true power of this stuff. And with that, I hand it off because I don't know enough about that.
Yeah, just very quickly on that as well, because Saswata will talk a bit about Thanos and how it builds on the fundamental building blocks that Prometheus started. Something that's worth considering as well is that I get asked a lot, and generally in the community, and this is related to PromQL being quite difficult to parse, which is, everyone's used to not using PromQL. Why is it necessary to have a specific system to handle time series data? And really, it's because of this high throughput, high cardinality data set that we have to ingest, that a time series database just makes a lot more sense. You have time series that come and go with the passing of time. You have scrape intervals and samples and labels that are very verbose, but samples that are very highly compressible. And if you were to arrange this in a column-based store, or however you decided to do it, that wasn't a bespoke time series database, you would run into much larger performance bottlenecks than if you use something like this. So it's very elegant design. It's from its foundation. I don't think TSDB has changed too much, has it, Jan? It's been a pretty core component to it.
I mean, the big change was Prometheus 1 to 2. There was a major restructuring of the TSDB, but that's also 7 years ago now. So,
as far as I've been using it, at least, that's how far history goes. So very quickly before we go into Thanos, I guess this is what your metrics might look like when you use them. This is probably what we would classify as platform metrics, as the question suggested, right? This is a node and the CPU, memory, and what's going on disk. And these are the kind of visualizations that you can generate from metrics. This is really good if you're in SRE and you just want to go and see what's going on. If you're building applications and you want to see how things are changing. And you can do this and project it across a distributed system that's running thousands of pods or thousands of containers. You don't have to constrain yourself to a single runtime, which is why it's so interesting and powerful. And those labels become very important in associating your data. Do we need to go through this? This is kind of a graphical. It's not very clear on the screen, but this is what your time series look like if you were to plot them on a graph, right? Samples over time, and then vertically you have the unique identifiers.
Yep. So yeah, thanks for that. And then comes Thanos in the picture, which is a bit difficult to explain. But yeah, essentially you can split Prometheus functionality into basically 4 different internal components, I think. The first being the scrape and storage, which basically scrapes all of your applications through by discovering them using the service discovery and then storing it in the time series database. There's the query engine, which allows you to query that database using PromQL. There's the rule and alert engine, which evaluates certain PromQL expressions and either generates new series or sends alerts to something like Alert Manager. And then there's the compactor, which is sort of a background routine within the same Prometheus process, which is in charge of just compacting TSDB blocks on disk for faster queries, right? And Thanos basically allows you to scale all of these parts or functionalities of Prometheus, right? And so it can be kind of termed as, we like to call it distributed Prometheus ++, right? Because its goal is to kind of provide a highly available and scalable set of components to compose a distributed Prometheus-based monitoring setup, particularly suited to multi-cluster workloads, right? And it tackles many of Prometheus's challenges, like vertical scaling limits that we kind of talked about, HA pairs, where you have high availability Prometheus pairs, but you want to deduplicate data between them. Or you just want a global view across your different Promethei that are there in different clusters, right? Or even if you want to long-term persist storage, and even things like multi-tenancy, for instance. But yeah, that's kind of what I would say Thanos is. And Thanos is split into various different components. You can run Thanos in a bunch of different architectures. What we've seen to be kind of common within Red Hat is this sort of receive architecture, where you have certain receiver nodes that get metrics remote written to them from different Promethei. They ingest it in their own local TSDB, and then you can query it using the Thanos querier. And Thanos querier is sort of this, I would say, magical central point, which allows you to query different metric backends together. So when I say metric backends, I mean essentially something that exposes the store API on top of some storage. So receive exposes store API over its local TSDB. It also ships over its TSDB blocks on disk to object storage for long-term persistence, and that's where you get the store gateway. And store gateway allows you to read that data from object storage via the store API and be able to query that data using PromQL as well. And so you can think of it as recent data being in receive and longer term historical data ending up in object storage, which can be queried by the store gateway. We also have a ruler component, and this is especially useful when you want to evaluate rules on a global level. Let's say you want to check error rates across all of your clusters, right? Or something else like maybe see temperatures across your server farm or things like that. And for things like that, you need to have a global query that runs every so often and gives you a new series. And ruler is really useful for that. You can also set in alerts that would get fired. And you have the Thanos compactor, which, as I kind of mentioned, one of the facets of Prometheus is doing compaction on disk. And for Thanos, we do it on a global level on object storage, where compactor compacts TSDB blocks into larger and larger blocks for faster queries. It also does a few unique things around retention. So it would delete too old data. You can set retention. And it also does something called downsampling, because when you're querying for multiple months worth of data, you probably don't want to load like a billion samples into a UI and melt your computer. You want to downsample that. And so it is in charge of like downsampling, maybe like from one sample every 30 seconds to one sample every 5 minutes or every 1 hour. So yeah, I would say like that's a brief description of Thanos.
For the downsampling,
Sure.
is that like, how is that done? Is there some sort of like aggregation that then gets the larger time block sample, or is it just like, all right, I'm just only going to grab like this is the top of the hour timestamp, I'm only going to get that?
Yeah, kind of. So like we have, so internally within the TSDB blocks, we store data in highly compressed smaller sections known as chunks, right? And for downsampling, we create a new chunk called as aggr chunk. And that basically, so like if you have scrape interval data of like one sample or one float value every 30 seconds, it will basically take that and aggregate it into like one sample every 5 minutes or one sample every 1 hour. It will also pre-compute aggregations, like common aggregations in PromQL, like sum, average, min, max, count, that kind of thing, and also store that value so that when you do queries like rate over like a month, or you do a count over a month, you don't load up raw data and have to like operate on that, but you can load up downsample count values as well. So it's a combination of multiple things. Tiny FYI is that this won't reduce your storage, it will increase your storage, but it will make your query faster. So yeah.
Yeah. Fun fact. So before I came to Red Hat as a reliability engineer, I was a quality engineering manager for a company that did IoT. And this was like, this was 4 years ago now. But anyway, no containers were involved. We had to do IoT data collection and aggregation on IoT gateways that ran like in customer buildings and like ran on we're talking Raspberry Pis, right? And so we're talking not necessarily in the order of magnitudes of billions of time series data records per day, but some of it was event driven and some of it was polled, and so it would be like 30 seconds, and we did the same thing, right? So we had we do it's like, if you worked in IoT, you've done this, right? So that you get all of your actual like per time series, either like one, and we even like did it like we were capable of doing by the second granularity. It just wasn't a business case, so why spend the storage on it? You can run it on a Raspberry Pi instead. We had beefier servers that could do way more. And so but yeah, we would do the same thing. So we actually would get the actual, like, just the time series of the raw data. And also then we had a job that went through and created that aggregate block as well. And it was for exactly this reason. It was for the ability to quickly see trend lines. Because we were talking like power consumption, and like kind of like it was like power, like really just like utility consumption was a huge like use case in this space. And so what really people were caring about is like, what is my trend line? And like they wanted to use that trending for forecasting, and you could get like way more accurate forecasting by actually having that finer granularity of data. But like for just kind of like day to day, like what they want to see, they just wanted to see the trend line. And so 15 minutes actually was like our roll-up interval. And so there's a lot of use cases to have different, like we called it a roll-up interval. There's a lot of cases to have a different roll-up interval, etc. But it's fun because what we're doing here with, like, when I say we, like holistically the industry with like Prometheus, Thanos, and this, so it's a pattern, right? This is a common pattern. Like there's no special sauce really to the logic behind it.
Fun story. Like we have users of Thanos in the upstream who are doing sort of like edge or IoT use cases. So we have users who ship metrics collection agents in their server boxes, and they get metrics back and store it in Thanos and are able to query telemetry for their product, which is server boxes, right? We have people who use Thanos to even get telemetry from NAS storages, like consumer NAS storages, which is really interesting to see, especially like edge cases like this, right? So definitely, I'd say like everything is common when it comes to like time series, right? So yeah.
Yeah.
Awesome. So we can talk a bit more about multi-cluster as well. I see we have a question about Thanos more specifically. Maybe we could address before we move on. So metrics being rejected when using remote write to Thanos, maybe metric duplication is one of those reasons. Why does that happen? And we miss metrics on Thanos, which is at fault here, problem with Thanos. It's kind of a big topic. There are a few reasons why a metric might get rejected. One of them is that a time series database is monotonic. It proceeds, is monotonic the right word? But anyway, it proceeds linearly in time. So if you, for example, send a sample for right now, and then the next request is a sample for an hour ago, Thanos will just, Prometheus as well, if you remote write to Prometheus, will just reject the sample and say, I can't go back in time and edit blocks because they're immutable. Duplication is one of those recoverable errors. Really, if you have, for example, a Prometheus HA pair, and they're both writing to Thanos receive, and you haven't set up the labels on which you would like to deduplicate them, then you might get two Promethei who are remote writing at the same time, sending the same metric, right? Because if they're a HA pair, they're scraping the same targets. And Thanos will just do a first come, first served. It will just accept the first one and reject the second one, if it is completely lined up on all of the labels. So it's not necessarily a bad thing. It's sometimes more of an info than it is an error. But there are a couple of very common ingestion, especially via remote write errors that you run into. Is there anything you want to add to that, Saswata?
Yeah, I'd say like the out of order stuff that you mentioned is tricky, and this is why within Prometheus upstream and in Thanos, there has been work going on the TSDB to kind of support out of order ingestion, but only up till a limit, let's say. And so you can set a configurable time, and then you can do some out of order ingestion on remote write itself. As for like this really depends on how you configure things. If you get duplicate data, you'll probably get a 400 status code with like a conflict or something. But I would check if you are missing metrics or if you see gaps in metrics. If not, it's probably fine. So, yeah.
Absolutely. So we've spoken a bit about the time series itself, the infamous time series. Prometheus, which is a really convenient and battle-tested way of gathering those time series in one place through a standard format, querying them and applying recording rules to them. And then we've spoken about Thanos, which really takes Prometheus, shares a lot of code with Prometheus, but just explodes out the architecture. Instead of a single container that's running, it's multiple containers that are doing all those individual jobs backed by object storage instead of disk or main memory. But more generally, the topic of multi-cluster observability is a big one. Generally, the trending is, I think I remember at least when when people used to run Kubernetes in the early days, they would run one massive server and they would segregate staging and production in the same cluster, and they would have hundreds of namespaces and everyone would access the same cluster, and that was all fine and dandy because the fixed cost of Kubernetes was quite high. Now with hyperscalers and hosted control planes, and also flavors of Kubernetes that are getting smaller and smaller. We spoke a bit about IoT devices, right? This is becoming a trend. You're now oftentimes running more than one cluster, and probably more than three, right? And generally that means they might have different networking requirements. You might not be able to access all of them. You might not want to access all of them. If you imagine you're a big telecoms provider and it's a cell tower running somewhere, you probably don't want to log into each individual cell tower to get information out that you need from your metrics. So really, multi-cluster observability is about aggregating this really fine-grained data into a central place so that you can provide some historicity, so you can have some way of going back in time and seeing how things are changing, but also so that you have one place where you can query it, the infamous single pane of glass that you hear a lot around in observability products, which is, I just want to see everything in one place. I don't want to have to log into different dashboards or keep switching between data sources. And this is a really tricky problem to solve, mostly because we've started off with a single container on Prometheus, and now we're going up, and there are certain things, fundamentals in the data that we're gathering that means that it doesn't scale particularly well.
So, I want to just kind of chime in too, because our people who are regular viewers will remember a couple episodes ago when some of our folks were like some of our other Red Hatters were saying, like, something that they sometimes recommend would be like one really big cluster compared to multi-clusters. And longtime viewers will know that my reaction was something similar like to, oh dear God, no. With the caveats that, of course, experienced Kubernetes users with, really good understanding of what's running on their cluster and so forth and a good DR strategy would be able to do this without too many issues. But I do think that, like, kind of the why of multi-cluster is, I think, sometimes still debated. I think we see it with our customers as they're like, why should I have two clusters instead of one large cluster? One large cluster is cheaper or can be cheaper or what have you. I mentioned earlier today, failure domains, right? Like, okay, is it really safe for you to have everything co-located? Because if that fails, like, how long does your DR take, and is that acceptable for your business case? Because building a new cluster takes roughly 45 minutes, and then you have to do all of the additional stuff. But like, what are some of the other, if you can share, if you know them, what are some of the other business cases that are like driving multi-cluster as the way that customers are going?
Yeah, it kind of ranges. As you mentioned, there are those who are very comfortable with the primitives in Kubernetes and using Kubernetes to run containers as orchestration for containers, that they want to push it into every possible far edge use case that they can get it in. Cars, telecommunications, all these different things. So the scope is getting really, really big. Generally, even in what we would call the vanilla use case, which is, I'm just building maybe some web services, maybe I have some databases that are hosted, and I'm running testing, staging, and production. It really varies on our install base. We have some metrics on it, at least from the advanced cluster management perspective, which is that most people are on less than 10, but there's a very long tail. The long tail are running thousands, right? So, and those could be thousands of very, very big clusters. So multi-cluster observability has become not just a buzzword, it's functionally impossible for a small set of SRE engineers to have to manually log into all of these different clusters to get metrics from them. But there are some interesting payoffs when you do multi-cluster observability at that scale, which is that you shouldn't maintain the same level of granularity. And you have to have that same iteration about the metrics that you gather and how you gather them, around like whether you should be bubbling them up to a fleet level. An example is if in a cluster you're gathering container level metrics and pod level metrics. That's really useful when you're in the cluster and you want to see if a pod has been recycled and what the metric is after it's been restarted. If you're tracking an SLO, a HTTP request rate SLO, you probably don't need a container level granularity to those metrics. You can probably calculate some kind of local maxima that you bubble up through your fleet of hundreds or thousands or even 10 clusters. That means that you're not paying a lot of cost in terms of object storage, in terms of egress, all these different things, but you functionally maintain the same like high level view, and you can still drill in if you really want to. So there's a few different kind of topologies that you can run with. And there's other concerns as well around multi-cluster observability, which is becoming clearer, which is, okay, it's all well and good. I'm collecting all of this data from this, 100 clusters that we run in our company. This is a metaphorical company, not a real one. But if I have 100 clusters and maybe I have 100 teams developing software on those hundreds of clusters, how do I manage access to that data? Does it really make sense if, for example, I'm a bank, that everyone can see metrics from highly sensitive parts of our stack, right? There's like, you start to get into the world of multi-tenancy, of managing access to metrics, of disaster recovery, reliability becomes really important. It's kind of the same as any typical distributed system where you have a lot more things to worry about at that scale, especially in multi-cluster. So the usages vary. The topologies the topologies are roughly similar, but the volume and magnitude can vary a lot. But everybody needs to access the data. They need to segregate it. They probably need dashboards recording those alerts. That problem set is very common. And we focus mostly on Kubernetes, although this is interchangeable, right? Even if you were to think about this outside in the VM world, we've been working with Red Hat Virtualization, for example, right? Who run VMs in Kubernetes. That's an interesting challenge about how you instrument and gather metrics for thousands of VMs that are running. So it's truly, a huge scope problem. I'm not sure if that answers the question. I went on a bit of a monologue about multi-cluster observability.
No, I think it did. Just kind of letting you know, like we can run a few minutes over if we have to, but I can't. There's the occasional ask of, can we get a 2-hour stream? This is exactly that stream that should be a 2-hour stream, but unfortunately we are running up on time. So I'm gonna let this go a few more minutes, and then we may just have to have you all back to do the other half of this talk.
That's no worries at all. Just to quickly caveat this all, right? There are you can run this yourself, which is what these open source projects try to do. It's what we try to do and what we try to simplify for users. And there's also vendors that you can go and pay that will do this for you, your Datadogs and so on, that will charge you a premium for everything that they ingest. So there are solutions to this. That doesn't mean that you have to run it yourself. We're perhaps purists and we like to run it ourselves. So this talk is angled at how you would run it yourself. And it's really attainable. We have users in the community on Thanos. There's a blog post. I think it's 2 billion series or something along those lines. 2 billion active series. So not even in aggregate. So there are truly, off the shelf, you can get pretty close if you're willing to pay for the compute to the scale that you will need. And then you just need some knowledge about how to scale it, which we can maybe talk about at a later date, because I see there are some questions as well about scaling.
Yeah, scaling could be its own stream, always. Scaling anything is always its own stream topic, because there's a lot of really big, like, if then, like, decision trees around scaling, and are you scaling you directionally and caveat, asterisk, right? So Put a pin in it. Maybe next time we'll talk about it.
Exactly. Mo would call it a hard problem. I think that's actually where you get to the fun problem, right? Because then you can start talking about like what's our failure domains, what are our expectations, and to seeing stuff, who can see things, what can break before we lose data. This all plays a role here, and that's really that's why we love distributed systems, right?
Yeah, and it's just impressive to see, the scale that people push these simple, well, I say simple, but these systems to, and how they use it, and how they use the data that they are retaining from all of their infrastructure. It's just pretty amazing to see. So yeah.
Just a quick call out for some of these technical questions in the meantime. There is the CNCF Slack, where most of us are on it. There are Thanos forums and Prometheus forums. Feel free to jump on and ask these kinds of questions. There's always people in there. The community is very welcoming. And we'll be able to talk about some of these challenges more. Saswata and I are working on the Thanos operator, which kind of solves for some of the scale problem, or how you reason about scale on Thanos. Saswata recently released the new Thanos PromQL engine, which is a bit of a rework of how PromQL evaluation happens when you have large distributed Thanos deployments. So there's lots of really interesting evolving work that's going into Prometheus and Thanos to try and enable higher scale and not more signals, but more formats. And like maybe Prometheus 3.0 Jan could be its own session as well.
Should be. Yeah, we're working on Prometheus 3.0. A couple more weeks and it'll be out. And last but not least, I also want to mention conferences, right? I already mentioned PromCon, which happened a month ago. Earlier this year, there was the first ThanosCon, single-day conference. You can find all these recordings on YouTube and probably other places. There's really deep technical information there. There's user use cases, deployments, whatever you want, you can find it online. So all recorded.
Yeah, and like just to add to that, there's also mentorship programs. So if you're really new into the space, or if you're a potential student, you might apply to mentorship programs like LFX and GSOP that Prometheus and Thanos do via CNCF, and work with our maintainers for maybe a few months, and get to see how you like it and how you like being an open source person. So yep.
And even outside of these programs, always welcome to contribute to Thanos, Prometheus, any of the observability projects. That we're always looking for more people to contribute to our projects. Doesn't have to be code. There's lots of things that you can do as long as you enjoy the project and have a little bit of patience. You'll do just fine.
I always say this. And I'll never stop saying it. As somebody who is a self-taught engineer, contributions to the docs are the single most important contribution anybody has ever done, right? Because a good doc helps people to learn. And then once you learn, you can attain mastery, and then that becomes a skill that you've added to your repertoire, right? And that is 100% how I have built my career. So please contribute to the docs, and thank you to every single docs contributor ever. I appreciate you so very, very much. So yeah, it doesn't have to be code. In fact, as useful as the code is, a good document about the project is it's the MVP, right? A project doesn't succeed.
The first thing that people see, right?
Yeah.
The greatest project with bad docs, no one is going to use, right? Yeah, so you're only as good as your docs, really.
100%. So it's if you're using a project for the first time and you see a small error in the docs, just make the contribution back. Follow the contributing guide. Obviously, don't just some projects want you to open an issue and then open a pull request that references your issue. That helps with the housekeeping and so forth. Every open source project has a contributing guide. Just go check it out, follow it up. If you don't feel comfortable making the pull request yourself, that's fine. Just let them know on Slack. The maintainers are, especially for CNCF projects, are super accessible. And everybody will appreciate you. You'll get your good karma, your good juju, your good, I don't know, other thing. I ran out. energy. There's probably like other things, right? You're gonna get that, and it's also just a good way of giving back to the community.
You get a contributor badge on your GitHub profile. That's why a lot of people do. So I'm just messing around.
Yeah, that badge is fun though. I'm not mad about it.
Yeah.
I got a couple badges recently on my GitHub profile, and then like because I have my GitHub profile attached to like some company things within Red Hat, then there's like propagate through, and I'm like, wow, they've gamified it, is what they've done.
Exactly.
It hits the dopamine center of the brain, and I'm like, ooh, shiny. It does the things. Right, we are 6 minutes over. Any closing thoughts? Obviously, everybody wants you to come back, so that's a done thing.
Sure, anytime. It was definitely a lot of fun to be here, and we can always gab a little bit about monitoring and Prometheus and Thanos.
Yeah, and we also have very lovely colleagues who look after tracing and logging, and they have their own challenges as well, and network observability. So we could probably start our own podcast. I'm just messing with you.
Probably.
Yeah.
Or you can just borrow mine for a few weeks.
Yeah, we'll just do a series of observability related talks. So yeah, we'd love to come back. It's a really interesting problem.
Awesome. Wonderful. Well, thank you so much. So we're over time. I will let you go. I know it's very late for some of you all, so thank you for joining outside of normal hours. I enjoyed it. I know the audience enjoyed it. I know the people who catch the recording later will enjoy it. I'm going to send it out to the Red Hat SRE team as well. I know that's going to be reviewed for most of everybody, but it's still really valuable. So we'll say goodbye. I'll remind the audience that until we see them again, to choose your technical debt wisely. I don't know what our next stream